Yeah, welcome everybody. So let we exercise by using raster calculation in ArcMap. This is just runoff generation raster calculation example. We do have a precipitation raster with 150 meter in centimeter per hour. There are precipitation values, that is 4 centimeter per hour, 6 centimeter per hour, 3.1 centimeter per hour, and 4 centimeter per hour again. And the infiltration rate in centimeter per hour is also displayed on the second raster, that is 2.2 here, and here also like 2.7. So we are asked to determine the runoff value, which is the difference between precipitation and infiltration. So the first thing that we have to do is convert both of them into text, then back into raster. Then by using raster calculator, we can calculate runoff. So this is the format to convert into text. So the first thing that you have to do is please open your notepad. Please open your notepad. This is your notepad. And write the raster information of precipitation into a text, and similarly the infiltration the same. In my case, I do have the file, so maybe I can copy this one, but in your case, please write the information in your notepad. Please write like this. When you write, don't make a space between two words, because that is the format of ArcGIS. No, you don't have to make a space between two different words. But if you want to separate those two different words, maybe you can use underscore like this. Underscore. So please write NCOLS, that is numbers of columns. NCOLS, that is 2 for the precipitation raster. NROWS, that is 2. Again, the corners are 0, 0, and the cell size is 150. And no data value, we don't have no data value, so minus N49. And copy the precipitation amount is 4 centimeter per hour, 6 centimeter per hour, 3.1, and 4. Please copy this one. When you finish, just save it. When you save it as precipitation. Save it with the file name precipitation. So go to file, save as, with the file name precipitation. So maybe let me create another folder on the desktop in my case, and let me rename it PhD students. So I can put the file here. The file name should be precipitation. Precipitation. Here, precipitation. And save. Do you have it? Yeah, next do the same for infiltration. To do the same for infiltration, don't open a new notepad. To make it easy, just open the precipitation, the already created precipitation notepad, and change only those values. Open the precipitation notepad and change only those values. The number of columns 3, number of rows 3, 0, 0. The cell size is different now, 100. And copy also the infiltration values. In my case, I don't have, so let me copy this one and I can put it maybe here in my notepad. In your case, write it. When you finish, please save it as infiltration. To do that, go to File, Save As, and write as infiltration. And save. After having this one, please open your ArcMap. That is the ArcMap window. In this ArcMap window, we are going to call upon those text files. As you know, you can't display a text file on the ArcMap, no? The data should be raster or maybe vector information. So what we are going to do is we have to convert those precipitation and infiltration text files into raster. So to convert that one, we have to go to conversion in ArcToolbox. In the conversion, we do have a format which is called ASCII to raster. In ArcMap, there is a well-known text format which is called ASCII, that is ASCII and Roman number 2. So ASCII to raster, it will display on the map. Where to find the ASCII to raster option? Please go to your ArcToolbox and go to conversion or conversion tools. Please expand the conversion tool just by clicking on the plus sign. Then go down until you get an icon which is called to raster. And please expand the to raster option. Then the first option what you get is ASCII to raster. That is what we are looking for. Double click on it. And please call upon the precipitation text file first, then the infiltration text file. You know where you saved the precipitation text, no? So please give the input ASCII raster file. So I put it on the desktop within the folder PhD students. So that is my file. That is a precipitation text document. Open. Then please specify again the output raster. The output raster maybe has the same file name like precipitation, but in that case it's just a raster information. Specify the output location. I can put it maybe in the same folder. Maybe I can go to a desktop and PhD students. Then here I can say precipitation and please write .tif. Let me convert into TIFF. So with the file name precipitation.tif, then save. And again, the output data type is optional here, but maybe with this example, let us select float. This is the one I told you. Please read when you have time what are the famous output data type in ArcMap. We do have integer, we do have floats, you do have double, and you do have also text format. So what is the difference between them? For this specific example, if you remember, we had a value with a decimal number, that is a precipitation 3.1. So if it is 3.1, we expect a decimal value. So if you expect a decimal value, you have to select either double or float. So in this case, please change into float. select plot, then click OK. Now if you see the status bar, it's just converting. After converting, maybe it will display here on the map window. Now it's just displaying. So this is a precipitation raster, which is similar to the one you saw here. That means which is similar to this one. And you check also the precipitation values. For example, the first grid cell has 4, no? Please check on the ArcMap. Here, check the precipitation value with the identify icon. You have identify here. Click on that and click on this cell. You can see values of 4. Yeah, you can see values of 4. And again, check here, that is 3.1. Check here, that is 4. And check here, that is 6, which is similar to this one. And please change the color here. Then maybe I can put it like this. In that case, you can see that you have 2 rows and 2 columns. And also you can see the resolution, that means the cell size. That means you can right click on the precipitation and go to properties. Precipitation properties. Yeah, here on the property you can see that the columns and rows are 2 by 2 and the number of bands is 1 and the cell size was 150 by 150. That's correct, no? And it was just a TIFF and the pixel type was floating and the pixel depth is 32 bits, which is similar to the example raster file. If you are okay with that, please add also the infiltration raster. That means do the same. Right click here and your input now is the infiltration text file that we created, no? So add the infiltration. It's just on the desktop inside the folder PhD students, then infiltration, open, and again save it with the file name infiltration.tif, save, and change the output data type into float again. Click on OK. It's just now calculating from text to raster. When it's finished, you have this raster which is similar to the infiltration rasters of this one. And again, change the color for a better visualization. I can change the color into here, or maybe let me change it to this color. Yes. Now you can see 3 rows and 3 columns. And similarly, check the infiltration amounts. The infiltration value in centimeter per hour for this grid cell is 2.2 centimeter per hour, which is similar to 2.2. And again, if you check the last cell, which is 2.7, that is 2.7 centimeter per hour. The question was to calculate runoff, which is the difference between precipitation and infiltration. That is the difference between these two rasters. Yeah, the precipitation TIF minus the infiltration TIF. But let me ask you one question. What would you expect on the result? It will be a 2x2 raster or 3x3 raster. Because as you see, the precipitation raster that we have is 2 rows, 2 columns, and the infiltration raster that we have is 3 rows, 3 columns. So what would be the runoff, which is the difference between the two? 2x2. 2x2. Yeah, we will get a 2x2 runoff. But what if do you like to have a result with 3x3? In that case, you should have to interpolate, no? Yes. So first, let me calculate the runoff by using a map algebra or a raster calculator, and later maybe we will see how we can resample the precipitation by using the infiltration runoff. Sorry, the infiltration raster information. In that case, to get a runoff which has 3 rows and 3 columns. First, let me calculate. To calculate the difference between the two raster, we have a map algebra or a raster calculator. Always, if you are in difficulty to locate inside the ArcGIS box, please search it. Please search it. For instance, now if you don't know where is the locations of map algebra inside the ArcGIS box, you have the option to search always. So the search option you can find here, near to the ArcGIS box, that is search. So click on that. So the search window will pop up. On this search window, please write which process do you want or which process are you looking for. For this simple exercise, we are looking for map algebra or raster calculator. Yes. So please write map algebra here. Map algebra and enter. Yeah, you can get spatial analysis map algebra, but if you are in difficulty, please write map algebra here and you can get it. It will show you where to find inside the ArcGIS box. For example, the first option is telling me that you can find the map algebra inside toolbox, system toolbox, spatial analysis tool, map algebra. And the raster calculator option is telling me that I can find it inside spatial analysis tool, map algebra, raster calculator. So what I'm looking for is the second option. So to find and to open easier, you can click here on the search. You can click; it will lead you directly to the ArcGIS box. That's the raster calculator. We do have the raster calculator window. With this raster calculator window, we are going to calculate runoff. The runoff is simply the difference between the precipitation raster and the infiltration raster. So please double click on the precipitation raster. It will come here. Double click on it. That is the precipitation raster minus the infiltration raster. And please specify the output location or the output raster with the file name runoff. Runoff.tif. Save and click on OK. It's just calculating the runoff from the to raster. Yes, now I do have my results. This is just a runoff raster. Let me change the color. Like I said, we do have runoff with 2 columns and 2 rows. The idea is just the runoff is the difference between the 2 rasters. It means this was the way how the ArcGIS calculate. That is the difference between 4 minus 2.2, which is 1.8, and 6 minus 4, which is 2, 3.1 minus 1.5, around 1.6, and 4 minus 2.7, which was 1.3. So if you examine deeply, the system ignore those middle values. Yeah, it ignored those middle values. That means these rows and this column, because our precipitation value was just 2 rows and 2 columns image. So what we can see on ArcMap is the same. You can check the raster or the calculated runoff. Then the first cell, the runoff was 1.8. So maybe you can check by using the identify tool. So if you click here, you can see that the runoff was 1.8, which is similar to this one. And similarly on the next cell, it was 2. That means if I click here, I can see that the runoff is again 2, which is similar to that one. That's why sometimes you need to have a runoff which is 3 by 3. So how you are going to do that? To calculate the runoff value with 3 rows and 3 columns, you have to interpolate the precipitation values. You know what do you mean by interpolation? You know what do you mean by interpolation? Interpolation means finding or calculating any value between 2 values. So in ArcMap, there are lots of interpolation techniques. I believe you know some, including kriging, spline, IDW, which is inverse distance weight, and there are also so many interpolation techniques in which each of them has some advantage over the other. And most of the time, the kriging, spline, nearest neighbor, bilinear, spline, all those interpolation techniques are included in ArcMap window. Please again, when you have time, read what is the advantage of one interpolation method over the other. Especially check kriging, spline, and IDW, which is inverse distance weight. Those interpolation techniques are the most interpolation techniques which is used by most of the researchers nowadays. So please check those interpolation techniques. Some of them has advantage over the other. So our aim was to calculate runoff and to have a runoff result with 3 rows and 3 columns. Yes. So what are we going to do is, for example, we had 2 rows, 2 column precipitation. That was 4, 6, 3.1, and 4, if you remember. Yes. So what are we going to do is interpolate between the 2. That means 4 plus 6 divided by 2 is 5. Yeah. And 4 plus 3.1 divided by 2 is 3.55. And 6 plus 4 divided by 2 is 5. So in that case, you will have a column and a row in the middle. So how we can do this one? Automatically in ArcMap. In ArcMap, to do this one, you have the options which is called resample. It means you are going to resample the precipitation data by using the infiltration information. If you remember, the precipitation grid share was 150, but the infiltration grid share was 100, no? So when we resample from 2 by 2 cell into 3 by 3 column cell, it means the grid size also will be changed into 100 meter by 100 meter. So in ArcMap, you have to find resample. Like I said, if you don't know where to locate, just search it. If you don't know where to locate resample in ArcToolbox, search it. So click on search, and write here resample. So the first search result is telling me that I can find resample inside data management tool, raster processing, resample. The easiest way, I can open just by clicking here, or I can go to the result says data management tool and raster, then raster processing, then resample. Double click on it. So our input raster is the precipitation. Our output data set is maybe let me say resampled precipitation, resampled precipitation.tif, and look, the output cell size is just optional here. That means the default x and y value, or the original x and y value, was 150 and 150. So you have to specify our output cell size. So what we need is to convert the precipitation cell, which was 150 by 150, and 2 columns and 2 rows, into 3 columns and 3 rows, which is similar to the infiltration raster. So click on this arrow and select same as layer infiltration. Same as layer infiltration TIF. If you recognize the x and y value automatically change it into 100, yes? Yes. So go down and you can see some parameters like the resampling techniques. There are different resampling techniques. Again, please read which resampling techniques is best. For example, you do have nearest, bilinear, cubic, and majority. Let me select cubic for this exercise and click on OK. It's just now calculating as you see the status bar. It's just resampling. Yes, now we will have a precipitation which has 3 rows and 3 columns. Which has 3 rows and 3 columns. You can check the precipitation values inside the grid. For example, this grid cell has precipitation value 5 cm per hour, and this one has 3.55, which is the summations of this grid cell and this grid cell divided by 2, and this one at the center has 4.27. Again, the summations of this grid cell and this grid cell divided by 2 is give us the precipitation value at the center in centimeter per hour. So now we do have precipitation 3 by 3. We had infiltration 3 by 3. So if we calculate runoff, we will have a runoff which has 3 columns and 3 rows, right? So please go to the raster calculator again inside the spatial analysis tool. The raster calculator, then calculate resample precipitation minus the original infiltration and save it as resampled runoff. Save and click on OK. It's just calculating, and finally we'll have the runoff, which had 3 rows and 3 columns. So this is our runoff with 3 rows and 3 columns. You can check the value inside with the identify tool. So the first cell has a runoff of 1.8 centimeter per hour, and the at the center also maybe 1.775 centimeter per hour, which is the difference between the two values. So it was calculated like this: 4 minus 2.2, 1.8, 5 minus 3, 2, 6 minus 4, and similarly for the other grid cells.